So hello everyone, and thank you very much for giving me the opportunity to present my work with my co-advisor, Professor Chung here. So I'm going to start with a background about the project and why did we started developing that project. So we have at Stevens Institute of Technology, we have the Craft Center, which is the center for research towards financial technology, and actually prompts academics like us to connect with practitioners like banks to help them use our emerging technologies and what we've accomplished in a more practical field. So based on our conversations with them, and Professor Michael Alice yesterday pointed out an important part about agent collaboration. Why do we do this? So after we talked with the practitioners, basically what they wanted is that a more structured framework for them to come up with how we can use these large language models and these different agents to accomplish a very specific task. Moving forward, actually, we're going to look at this from an RPA-driven workflow. Xiaoyu yesterday did an excellent job yesterday illustrating how large language models are now integrated into more rule-based procedures within the RPA framework. And that's why we're going to look at this from the lens of an RPA-driven framework workflow. And before that, I'm just going to go over the trend of how did we progress through process automation through time. And I'm going to show you 3 different exercises on multi-agent collaboration. And I'm going to show you also, I'm going to give you also the opportunity to do a very small hands-on exercises, and you'll have access to this through the Google Drive. Our project is titled the Prompt-Based Cognitive Load Measurement Framework for RPA and Auditing with Multi-Agent Collaboration. So moving on through the process automation, we started with RPA that also looks at more rule-based tasks with very specific conditions to come up with that procedure. So this procedure actually has a rule-based, repetitive, mundane task. And what we do is that we mimic these human clicks to come up with the same procedure over and over again. Later on, we developed to intelligent process automation. So what intelligent process automation did is basically it elevated somehow RPA, and it introduced some flexibility as you start first by using a different technology to transfer unstructured data to structured data, and then RPA kicks again. Now on, actually, we're taking this even much farther, right? Marco also talked about cognitive process automation, and that's what we're actually doing these days. So what's cognitive process automation? Actually, it's the process of using multiple LLM-based agents to come up with the same procedure to accomplish a very specific task. And we're going to go over why do we do this and how do we do this. And at the same time, as we go through, we need to understand why do we use these LLM-based agents, and at the same time, the appropriate number of LLM agents to come up with, to proceed with a very specific audit task. So here, even a closer look at the differences between RPA, IPA, and CPA. As you can see, the ones highlighted in red, the most structured difference between them is that the CPA works mostly with highly unstructured data, and we look at non-repetitive tasks. So that's one audit procedure, and these multiple LLM agents will work all together to proceed with one very specific audit task. And as Xiaoyu started with yesterday, actually a lot of RPA vendors have started integrating large language models to the RPA workflows. And this is very important. And the perceived benefits of them are very visible, actually. So one of them is that we need to first process complex and unstructured data for RPA to kick in again. This is one. Two, it adds some flexibility to the RPA workflow, right? Because, for example, if we do one mistake while configuring this RPA bot, everything's going to crash. So it adds some flexibility when you use large language models in that RPA framework. And we're going to stress on that point even more. So once we're using a large language models in RPA, a good question can be, do we need to use, for example, multi-agent collaboration to come up with these, to accomplish a very specific audit task? So when it comes to multi-agent collaboration, they're actually divided into three properties that we need to actually look at. The first is the agent itself, which is an LLM-based agent, and it's usually initiated by a prompt. The second is the human input, because definitely in an audit task, the human in the loop should be there and should be existent. However, this human in the loop process is somehow manageable in a multi-agent collaboration framework. So basically, the auditor will decide the level of engagement with these LLM-based agents, depending on how subjective or how much the task requires professional judgment. The third is the tool, which are the functions given to these LLM-based agents to come up with very specific tasks. And before we move forward, I wanted to show you exactly how these these multiple agent collaboration works. So I'm going to show you three different exercises. And before that, I'm going to show you two differences between how agents can collaborate. One of them is that consider these as three agents, agent A, agent B, agent C. So they'll converse with each other in a very unstructured way. What I mean by an unstructured way is that A will talk to B, B will talk to C, and then C will talk to A in a very unstructured way, up until they have some consensus on a given audit task. Alternatively, there's another process which is called hierarchical multi-agent collaboration, where that blue agent, whether it's a human or an LLM-based agent, actually delegates some of these tasks to different agents, and the input of one agent will become an output for the second agent. So you can see that there are different ways for us to configure these multiple agent collaboration, depending on the actual audit tasks that the auditor needs to perform. Before we move forward, actually, I'm going to show you three different exercises on how can we use multi-agent collaboration with very specific prompts, very simple prompts to give you just a clue on how these actually work. So here for this exercise, I'm using actually Autogen, which is an open source framework for you to actually configure different LLM-based agents to work together in a very specific way. So I started by importing the packages and libraries, and then here I add the load. I load the configuration of the LLM from a JSON file that has the name of the large language model and as well as the API key. And here I define an agent and I call him assistant. And also I configure the large language model for that assistant based on the JSON file. And a very important thing when using Autogen is that there's a user proxy agent which actually is going to mimic us. And this is how we're actually going to interact with this assistant when needed to come up with a very specific task. So for example, you can see here, the human input mode here is terminate. So once we put it in terminate, it's going to ask for our prompt at the very beginning of the task. If we turn it to always, then as long as the assistant does one specific job, they'll ask for our input. So you can see the level of human in the loop actually varies, and it's somehow manageable. And to illustrate how this works, I'm going to show you this is a very simple exercise. And what I asked them to do is to generate a table with the daily stock prices for Tesla from October 10th till October 20th. So you can see here the user, which is the first, which mimics us, started with that prompt. And then the assistant started with importing important libraries, packages. They also defined the ticket for Tesla. They loaded the package of Yahoo Finance to come up with that specific task. And as you can see, because I pressed terminate, because the human input mode were terminate, they're asking me for my input at the end. In other words, they're asking me, do I need to do anything else based on the actual output received, or is at the end? So in that case, I'm just gonna hit exit. And the actual process is done. And I'm gonna show you the actual output of that. So as you can see in this specific example, so they started by getting the stock prices for Tesla from October 10, October 18, but the problem is this is not the actual prices of Tesla. So that's why sometimes we need to actually work more on the prompts. Sometimes you need to add multiple agents to come up with that specific answer. And that's why that's a perfect illustration on why do we need sometimes even more assistance or sometimes less assistance to come up with a very specific task. And the second exercise that we're going to look at is more towards the hierarchical. So here I configured 3 different assistants to come up with different quotes. So assistant 1 wants to come up with a quote. The second assistant wants to come with the second quote. The third wants to create his own quote. And now we're going to actually move on and process this in a very sequential way. So what I mean is in sequential way is that assistant 1 will deliver to assistant 2 and assistant 2 will deliver to assistant 3. And sometimes this is very important and that's how actually we work and sometimes in the audit, right? So what we do is that sometimes we move on by collecting the data, then the data moves to be analyzed, and then the analysis moves to the interpretation process. So that's why this procedure moving from one agent to the other is very important, and sometimes relying on a sequential flow of LLM-based agents can help us achieve better output from generative AI. So here, as you can see, these are the examples of how we can see, we can look at multiple agent collaboration. And moving forward, so the big question comes here, how many agents should we use for a very specific audit task, right? And this is how we actually, we got motivated is that the industry actually needs a very specific framework to actually use these multiple agent collaboration to actually speed up the utilization of such generative AI. That's why we actually introduced more of a structured way to come up with our cognitive load measure that has its specific components. And what we also do is that based on that cognitive load measure, we come up with the number of agents, and then we come up with the certain RPA activities that come along with these agents. And at the end, we still need that human in the loop. Therefore, we also need to introduce, or we need to examine how are these, how's the human input appreciated in a very specific audit task. So to come up with our cognitive load measure, we actually relied on a specific theory that's more related towards education, but we revised these definitions to help us understand where the cognitive load comes from a very specific task. So in our case, intrinsic load actually represents how complex the actual task is, and we can perceive this as the number of steps that we're actually going to use to come up with that audit task in an RPA-driven framework. And the extraneous load arises from the way information is presented. And as you can see, sometimes RPA workflows can get very complex. You're using multiple websites and multiple Excel sheets to come up with the perfect answer. So this is the extraneous load, which is the load coming from everything else except the actual task. And definitely we have the germane load, which involves the effort invested in understanding and applying information. So this is more towards the task structure. Is it more towards the objective part, or is it towards tasks requiring more professional judgment. And we all know that, for example, RPA does not really work well with tasks require professional judgment because it highly depends on rule-based activities. Moving on, the components of our cognitive load measure, we look at the instruction density, which is analyzing the complexity of a given audit task. So, for example, when we need to configure how we can move from step A to step B, we need to actually understand the flow of process, and we need to determine the number of steps to come up with that audit task. The second is the decision point complexity, and this is very important as well because we're going to look at the if-then statements, and they might be a lot. For example, let's say you're actually taking information from a website and you're looking for that exact phrase. So what happens if that exact phrase has two clicks? You find the same exact phrase twice. What do you do with this? Do you actually take it both, or do you actually miss, or do you actually take a note of it? So these if-then statements actually even elevates the cognitive load of a very specific task. Next, we look at the UI interaction. For example, we evaluate the number of interfaces or screens that will be actually utilized to come up with the task. And finally, the cognitive demand labels, which captures the complexity of actions required. So what we actually did is we used ChatGPT. We configured our own ChatGPT app. We added a lot of information to how we come up with that cognitive load measure based on our strict definitions. And our input was the actual audit task, and the ChatGPT-based app had also the components of our cognitive load measure. So what we did is, we came up with that measure, and then we wanted somehow to validate our measure. So what we did actually, we went across the paper, and what that research paper did is that they dissected multiple audit tasks based on the audit procedure, whether it's substantive testing or risk assessment, and they rated on how structured that task is. So as you can see on the x-axis, the task structure, so as we go to the right, it means it's not structured. So as you can see, as the task structure gets deteriorated, which means as the task structure becomes unstructured, the cognitive load measure actually increases for that audit task. So we can see that there is an upward trend with how unstructured a task is and our cognitive load measure. An example of these that we use is that confirmation of recorded sales transaction by the customer, or vouching recorded receivables to supporting documentation. Next, we also, based on our cognitive load measure, which is our building block to come up with the number of agents, we also inferred on the number of agents that we're actually going to use based on our cognitive load measure. And next, we asked for the RPA components, which are the list of RPA activities to come up with a very specific task. And finally, what's that human in the loop, or where do we go? Where is the human intervention much appreciated in a very structured RPA-driven workflow? Next, as you can see here, we plotted our cognitive load measure to the number of agents. So as you can see, as our cognitive load measure increases, the number of agents that will actually will be assigned to that audit task goes up as well. So there's a positive relationship between the cognitive load measure and the number of agents that will be assigned for a very specific task. And I believe you guys all have the access to a Word document. And with that Word document, you'll have the ChatGPT-based app. And I added to you guys 4 different audit tasks. And what you actually can do is you can prompt this audit task into the ChatGPT-based application, where you will get the cognitive load measure of that very specific audit task. So in that case, what we're actually going to do is, that was my prompt, which analyzed the following audit task description and provide a cognitive load assessment while strictly abiding to our rules. And what was the audit task? The audit task was to obtain the client's product names and prices from waiver.com and transfer them into an Excel sheet. So when it comes to the different components of our cognitive load measure, we started, remember that the instruction density is more about the steps taken to come up with that Excel file at the end. So we need to start by accessing the website, search for the product, capture the product name, capture the product price, store each in the designated cells, and then repeat all over again. And it has a score of 6. And next, we look at the decision point complexity. So for example, what happens if we search for a product that's not found? What do we return? How do we deal with this? Next, we look at multiple products with similar name. Let's say, for example, you're searching for the word sofa, for example, for a very specific firm, and the output actually is multiple product names with the same name. So what do we do with this? We actually need to handle this within an RPA-driven framework, which also adds to the cognitive load measure. Third, we look at the URL interaction phase. So we have the Excel file and we have the browser interface, and then at the end we have the cognitive demand tables. So at the end you can see these 4 components are weighted, and in this particular case they were equally weighted across the 4 components, and we have a cognitive load score of 5.75. So the big question here is, so what? Based on this cognitive load measure, actually we're going to come up with a number of agents to help us move forward with configuring our RPA-driven framework. So the agent recommendation here was 2. When agents choose a task to handle the conditional logic interaction across interfaces, and one actually works on the data entry. And also the ChatGPT-based app recommended the specific RPA activities that we need to actually use to come up with that RPA-driven framework. And actually I did this exercise myself, and these RPA activities are pretty accurate. Finally, the human in the loop. Here we're looking at a human review is recommended where the product name does not match or there are subtle differences between the exact word that we're actually filtering for. So with our research so far, we moved from first, the industry has been asking for a very specific framework to govern how to actually utilize multi-agent collaboration, but at the same time, it might become very costly, especially if you're using a lot of agents to come up with a very specific audit task. And that's why we took a 1 step backward. And what we did is that we took a very specific audit task. We calculated the cognitive load measure based on a predefined criteria, which is drawn upon the cognitive load theory. And then what we did is we inferred the number of agents based on the cognitive load score itself. And that's how we actually move forward with coming with our RPA driven workflow. I think we have like 1 or 2 minutes. So if you guys are interested, what you actually can do, here's the ChatGPT based app that I've actually configured. So this is the ChatGPT based app that I've configured, and what the actual prompt you're going to be using. So you have a Word document with 4 different audit tasks. So all you need to do is actually come up with that audit task, place it here, and the cognitive load measure, the number of agents, and why do we need these number of agents will be the structured output. Also, they'll come up with the weighted components for this cognitive load measure, and that's how we shape our RPA-driven framework. So that's it for today, and thank you very much for giving me the opportunity to present my work. Thank you very much.